Today we're going to talk about how you can evaluate logarithms using calculators. And there's three different ways we're going to do this, and we're going to go from the most specific to the most general. So the first way is if you are given the value of two logs, then you can use those two logs to evaluate certain other logarithms. So for example, we are given that the log base 5 of 4 is equal to 0.861, and we are told that the log base 5 of 9 equals 1.365. So we can do that to evaluate this log here. So it's log base 5 of 4 over 9. We know from our properties of logs that we talked about that if we are dividing in a singular log, we can separate that as two separate logs with a subtraction sign. So 4 is on the top, so it's going to be log base 5 of 4, because like I said, 4 is on the top, minus the bottom here, log base 5 of 9. Well, like I was saying, we know that log base 5 of 4 is 0.861, and log base 5 of 9 is 1.365, so we can make that substitution. 0.861 minus 1.365. So 0.861 minus 1.365. And that is equal to negative 0.504. So that means this log base 5 of 4 over 9, is equal to negative 0.504. So we substituted what we knew. And again, we had to have been given this information up here to figure out this log. All right, now letter B says log base 5 of 36. Well, look, we don't have 36 up here. We have log base 5 of 4 and log base 5 of 9. But we know that 4 times 9 is 36. So we can rewrite this as log base 5 of 4 times 6. Sorry, not 4 times 6, 4 times 9. Our properties of logs say that if we are multiplying, we can rewrite this as addition. So this is equal to log base 5 of 4 plus log base 5 of 9. Now, back here, it didn't matter if I did 4 times 9 or 9 times 4 because we are adding. And with addition, it doesn't matter which order we do it in. So now that we have log base 5 of 4 plus log base 5 of 9, we can substitute it with these up here. So log base 5 of 4 is 0.861 plus log base 5 of 9 is 1.365. So when we add those, 0.861 plus 1.365, we get 2.226. Now, this one, log base 5 of 81. Well, how do we get 81 from any of these? Well, we know that 9 to the second power is 81. So we can rewrite this as log base 5 of 9 squared. Our properties of logs say if we can take this exponent and put it out in front. So this is going to be 2 times the log base 5 of 9. And we know that log base 5 of 9 is equal to 1.365. So this is going to equal 2 times 1.365. 2 times 1.365 is 2.73. So this skill that we're talking about here, using your properties of logs to evaluate, it is becoming more and more obsolete or less common to use because our calculators can do so much more on their own, where we wouldn't have to do stuff like this. But it's still good to know and be able to recognize and apply those properties of logs, knowing that, all right, if we are dividing, we can rewrite it as multiplication, or rewrite it as subtraction. If we are multiplying, we can rewrite it as addition. So these are properties you should still know how to use, but we're going to be focusing on using our calculators more efficiently. So on our calculator, we've talked about that it only has buttons for base 10 and E. We can use something called the change of base formula that allows us to calculate any logarithm. So what that means is that if we have log base C of A, we can rewrite this using division by log base B of A divided by log base B of C. Notice C is your base. C is in the bottom of the fraction. And the bases are the same, meaning we could make it any base we want. So in our calculators, if we have a log base C of A, we're going to rewrite that as log base 10 of A divided by log base 10 of C, that base. And we know that when we type in log in our calculator, it's an invisible 10. We're not going to see that base, but I wanted to emphasize that these bases are the same. You could also use the natural log, the ln. So you could say the ln of A divided by the ln of C, and you're going to get the exact same answer. So when we start doing examples using the change of base formula, you will see this a lot more clearly, and it's going to make things a lot easier. So on the next page, why would you use the change of base formula? When you don't have enough information to calculate a log otherwise. So like in our first examples up here, we had enough information to calculate them otherwise, but down here with these examples, we don't have enough information. So it says evaluate log base 6 of 11 using common logarithms, that's base 10, and natural logarithms, round to the nearest thousandth, so that's 3 decimal places. So log base 6 of 11, we're going to write this as log 11 over log 6. And that's what we're going to type into our calculator. So log 11, and we have to close our parentheses, divided by log 6. That gives us 1.338. And we could also use natural logarithms. So we could do the ln of 11 over the ln of 6. And we should get the exact same answer. .338. So that change of base formula allows us to calculate these logs differently. like up here, log base 5 of 81, if we use a change of base and said log 81 divided by log 5, 2.73, which is exactly what we got when we did it the other way. So that is why this method here is becoming less and less common, because we are able to do the change of base formula. So we're going to use change of base formula for to evaluate these logs. You can use either the common log, log base 10, or the natural log. So log base 16 of 26 is equal to log 26 over log 16. Again, the base goes in the bottom of your fraction. So log 26 divided by log 16. And we get 1.175. Here, this one is going to equal log 13 over log 5. Not base 5, log 5. And you get 1.53936, so that rounds up to 594, 1.594. So the change of base formula is easy to use, and it can be used on any calculator that has the log function. Even those inexpensive scientific calculators have log base 10 and the natural log, so you can evaluate these using any type of scientific calculator. Now, the graphing calculator, the TI-84s that we use, have a way to type in a base. So to do that, I'm going to follow these steps here, so let me move this over. So we're going to press alpha, this green button, and the window button, which is right up here next to y equals. And you see the fifth one down says log base. We go down here, hit enter, and now we can make these numbers exactly what we want in example A. 2.2, then press the right key to type in 22, and when we hit enter, we get 3.920. So again, you can use the change of base on this one as well. You could do log 22, close parentheses, divided by log 2.2, and you get the same thing. I'm just showing you how to use these different tools. So let's do letter C, and then I'm going to have you try letters B and D. So alpha window, go down to the fifth option, and 332. And we get 3.155. All right, pause the video and try these two problems over here. And once you're done, unpause it to see what you get. All right, so these are the answers you should have gotten. And like I said, you have multiple tools now. Sometimes I think it's quicker to type in, the log button on your calculator and using the change of base formula instead of having to do alpha window, then go down to the fifth one, and so on. So you have those options to choose from. So thanks for watching. Make sure to like the video and subscribe.